Okay, so here's the second example I said to have a look at. So you can see we've still got this cos t and sin t, but now we've got this extra part to it, this e to the negative 0.5t. So hopefully you've had time to think about how that will affect that circular motion. What I'd like you to do to begin with is to do part A, find the position of the particle at these different time points and show these on a coordinate grid. The way I've done that is I've put them in as two functions into the graphing document, and then I've used the table. I've gone to the menu, I've changed the table settings so that it starts at 0 and it increases by pi over 2 as the steps, and then it's quite easy to read the points off. So pause the video, have a go at that, find those coordinates and try plotting them. Hopefully you have managed to find all those. I've put them into a little table here. As I said, I made sure the step length on the table was pi over 2, and it made it really easy to get these values. And then when we plot them, you can see I've plotted them in blue, and you may have guessed it already, or you may have thought it through, but you can see that rather than being a circle, because of that negative exponent, as time gets bigger, this part of the function is going to get smaller. So the radius of our circle is going to decrease, and we end up with a spiral. And it finishes over here on the x-axis. If we continued, it's going to keep on spiraling towards the origin. You can see I've kind of like drawn where that will go in purple. Doing anything else with this is going to become a bit more challenging, isn't it? If we try to find the velocity vector, which is what you're going to do in part C, these functions are a bit more complicated. You can see that we've got a product, we've got one function multiplied by another function. You can also see function u, you're going to need to use the chain rule to differentiate it. Luckily, it's one of those like relatively straightforward chain rules where it's just a linear inside function. So we're just remembering to multiply by that inside function. So have a go at finding the velocity function and then having a go at part D. Once you've finished, you can check your answers. I've put them over here to the right of the question. Okay? All right, once you've done that, you've got to decide, do you want to go back and take a look at the first example? If you think this is a topic, this is the point where it's going to get a little bit too challenging for you, I would say it would be really sensible to just move on and spend some time looking at these examples. We are at the more challenging end of this vectors unit. So this, like that first example, is really for students who are aiming for the very highest grades. So decide what is most appropriate for you, and good luck with it.